Next topic, inverse Laplace transforms. So far we have learned Laplace transform. Once you understand the concept of Laplace transform, then automatically we can solve the problems of inverse Laplace transform. Now observe this one. What is inverse Laplace transform? Previously in Laplace transform we are getting the function in terms of t. Means we are applying Laplace transform at that L operator, Laplace transform operator for f of t. Means the question in terms of t. Every question will be in terms of t. Then you will get the answer in terms of s. Now here in reverse order, the question in terms of s, you will get the answer in terms of t. There I wrote there Laplace transform of f of t equal to f bar of s. Every time I told f bar of s. Why should I tell every f bar of s? Because the answer is in terms of s. That's why the total answer we are treating as f bar of s. Now the question is L inverse of f bar of s equal to f of t. Means in terms of s. That inverse L inverse is nothing but inverse Laplace operator. L inverse of f bar of s equal to f of t. Now already basic some formulas already we have done it in Laplace transform. Those formulas only. Suppose you know very well Laplace transform of e power at. E power at is the formula is 1 by s minus a. Then what is that? You send L this side. Then what will happen? L inverse of 1 by s minus a. What is the remaining in LHS side? E power at. Means inverse Laplace transform of 1 by s minus a equal to e power at. Means you got the point here very clearly. Just we are applying L that side, we are sending L that side, means it becomes L inverse. Inverse Laplace transform of 1 by s minus a equal to e power at. Like this. Now another example. Laplace transform of t square. What is that answer? 2 factorial by s cube. 2 factorial by s cube means you send L that side. L inverse of 1 by s cube. Now observe this sentence very carefully. L inverse of 1 by s cube. Actually the answer is 2 factorial by s cube. The 2 factorial is nothing but constant. If constant is missed, then you can send that constant that side. What is that? T square by 2 factorial. L inverse of 1 by s cube is t square by 2 factorial. Otherwise L inverse of 2 factorial by s cube is just t square. Right? Whatever that constant is available, if you miss that constant, you can send that side t square by 2 factorial. Now I will explain one more example. Suppose Laplace transform of cos at. Cos at is, what is that answer? S by s square plus a square. S by s square plus a square. Then when you are sending L inverse that side, then L inverse of s by s square plus a square is cos at. Means the question L inverse of s by s square plus a square is cos at. The question in terms of s means, what is s here in terms of s means s by s square plus a square. The answer is cos at. Now observe this. But if s is missed, you do not send s that side. Variable we cannot send that side. Previously 2 factorial is missing, then that's why we are writing t square by 2 factorial. If the same thing, L inverse of 1 by s square plus a square, the answer is, now actually this answer is sin at by a. Actually what is the Laplace transform of sin at? Laplace transform of sin at by s square plus a square. Then a is missing here. L inverse of, I am saying here, L inverse of 1 by s square plus a square means the answer is sin at by a. Now like this we can apply the inverse Laplace transform. Now using we have some basic definitions I explained here with the table. This side, one side I am writing here Laplace transform of all basic formulas. Immediately I am applying inverse Laplace transform. You focus on the second part. What type of formulas we are getting? L inverse of this much. L inverse of e power minus at, like that. L inverse of some basic formulas that I have given to you. Observe the formulas very carefully. The next one.